Welcome to Tomorrow Unveiled, the show dedicated to making sense of the exponential acceleration happening right now across science, technology, and society. If you blinked last week, you missed a seismic shift in the world of artificial intelligence. We're talking about an inflection point where the theoretical promise of autonomous systems agentic AI became a verifiable geopolitical and industrial reality.
That's absolutely the consensus across all the sources our research team reviewed. The last 7 days have been, well, astonishingly synchronized. It's signaling not just evolution, but a phase transition.
So what's our mission today on Tomorrow Unveiled?
Our mission is to cut through the noise. We're filtering this massive information stack. Our dedicated research team has pulled together articles, research papers, even internal communications. We need to find the core corroborated signals that show these fundamental shifts in AI capabilities, in governance, and in real-world applications.
To really grasp the transition from what we can now, I think, safely call the chatbot era
Oh, for sure.
to the true reasoning era.
Exactly.
Okay, let's unpack this then. The central theme defining this moment seems to be the maturation of these AI systems. They're no longer just conversational text generators.
Not at all.
They are genuinely autonomous agents capable of complex, multi-step planning and, crucially, execution.
Execution in the real world. That's the key. This is the shift to agentic AI.
Where the system actually initiates action, it corrects itself when it hits an obstacle. And it continues toward a goal without constant human oversight.
And what's fascinating here is just the sheer simultaneity of it all. This wasn't a single isolated event.
No.
We saw head-to-head releases from the major frontier model giants, GPT 5.2 and Gemini Deep Research. We saw profound hardware breakthroughs that physically enable this new scale of intelligence like 3D chips.
Right.
And then we saw these major regulatory shifts like the U.S. executive order that will shape the political and commercial economy of AI for years.
Yeah.
It's an escalation on all fronts.
Let's start with the models themselves, because this is where the power really begins. For you listening, I think the key thing to understand is the new battleground. It's no longer just about predicting the next word perfectly.
Right. That's what researchers call System 1 thinking. It's fast, intuitive, associative.
Like muscle memory for language.
Exactly.
Yeah.
But now the competition is focused squarely on System 2 reasoning. And that demands intensive internal computational effort, or what the field calls inference-time compute.
So inference-time compute is basically just thinking time.
It's the computational equivalent of deep, slow contemplation.
Yeah.
This is the model being forced to think, to self-correct, and to iterate on complex problems before providing a final, verifiable answer.
And we're seeing this from both camps.
Oh yeah, we have clear evidence that both Google and OpenAI are prioritizing architectures that allow for these long internal chains of thought. They're moving beyond simple retrieval and summary. This ability to execute long-horizon tasks that require multi-stage planning and might take minutes, even hours to resolve, that's what truly defines the agentic era.
Okay, so let's dive into Google's major release, the Gemini Deep Research Agent. This is built on Gemini 3 Pro.
And it's designed specifically for those long-horizon tasks. It's a true paradigm shift.
So it's moving far beyond what we used to call retrieval augmented generation, or RAG systems.
Miles beyond. The RAG systems of the past, they simply pulled documents and summarized them.
But they didn't really understand them.
Often not, no. They didn't get the connections or contradictions between those documents.
Yeah.
Gemini Deep Research is fundamentally different because it's powered by reinforcement learning and operates on this continuous, sophisticated loop.
Which makes it truly autonomous in its research process.
It does.
I think this is where we can get a great visualization for everyone trying to understand the mechanism here. Imagine you give the agent a hugely complex prompt. Something like analyzing supply chain vulnerabilities for a specific rare mineral,
Okay.
detailing extraction methods, and identifying geopolitical risks in, say, 3 African nations.
My massive task.
Right. So the agent doesn't just search once. It starts with what they call iterative planning.
Which means it's breaking that massive task into a precise sequence of sub-questions and dependencies. It's making a project plan.
Exactly. And that plan dictates its next action, which is autonomous navigation.
So it executes the search, reads the initial documents, and then, and this is the critical part, it evaluates its own findings.
So it thinks about what it just learned.
It does. It doesn't stop there. It identifies precisely where the knowledge gaps are, what piece of information it still needs to connect the dots, and it formulates entirely new search queries to fill those specific gaps.
So it's reasoning about what it doesn't yet know.
Exactly. Continuously improving and enriching its own research pool until its initial plan is fulfilled.
And then it moves to the final step.
Synthesis. It ingests data from incredibly diverse formats, PDFs, web pages, even structured data tables, and outputs a coherent, structured report.
Okay, so if I'm getting this right, it's not just finding books and handing them to you.
Yeah.
It's reading those books, connecting disparate ideas across all those sources, filling in the gaps with its own follow-up research,
Uh-huh.
and then writing a complete report in a precise format you explicitly requested, like a specific JSON schema for an internal database.
You've got it. That level of steerability and multi-step execution is transformative for enterprise use.
And the performance speaks for itself, right? Based on the benchmarks our research team analyzed.
It really does. Deep research is establishing new state-of-the-art metrics for reasoning depth. For example, on Humanities Last Exam, or HLE, which is a really rigorous data set designed to be unsolvable by simple retrieval, it scored 46.4%.
That sounds impressive.
It is. And even more telling is its performance on Deep Search QA at 66.1%. That measures its ability to synthesize information across several documents to answer a single question.
Multi-hop, they call it.
Right. And its proficiency on the BrowseConf benchmark was 59.2%. That one is particularly important
Why that one?
because it demonstrates the agent's ability to act in the physical web environment, clicking, logging in, and extracting structured data autonomously. It's not just reading, it's doing.
This level of reasoning depth, it effectively democratizes complex research. It could drastically accelerate fields like medicine, finance.
Absolutely. Which brings us to the infrastructure play. This is where it gets really interesting in terms of Google's long-term strategy.
They're pushing something called the Interactions API.
They are. They don't just want you on the Gemini website. They want to be the back-end intelligence for the entire global software ecosystem.
So it's about embedding this intelligence everywhere.
That is the strategic pivot. The Interactions API is designed to embed Gemini's agentic research capabilities directly into third-party software.
Like an ERP system in a big company.
Perfect example. An enterprise resource planning system. Instead of a human analyst having to manually use a chat interface to research a vendor, the ERP system itself can trigger a deep research task via the API. So it could, say, vet a new vendor autonomously. It searches the web for litigation history, credit risks, and returns a structured, verified JSON object directly back to the ERP.
So it completely bypasses the chat interface. The AI intelligence becomes invisible, embedded, ubiquitous.
Pure, behind-the-scenes automation.
And we can't overlook the fuel for all this. High-quality content. Our research also confirmed a crucial pilot program that Google announced.
Yes, partnering with major global publishers like The Washington Post and The Guardian.
Which is a critical commercial and legal move.
It is. The agent needs high-quality, verified data for its autonomous navigation phase, not just the Wild West of the open web. So by paying these publishers for the right to generate AI-powered summaries and audio briefings, Google is essentially negotiating an economic treaty.
They're trying to insulate themselves from all the copyright litigation.
Exactly. Securing preferred source status. This basically creates a two-tier information ecosystem. Verified, licensed, high-quality journalism for the AI to ingest, and the unverified public web for everyone else.
Okay, let's shift gears to the competition. OpenAI released the GPT 5.2 series almost immediately after Google's announcement.
The timing was not coincidental.
Reports from our research team indicate this was characterized inside the company as a code-red response. It was all about reclaiming that narrative supremacy in the reasoning race.
The competitive context is undeniable. GPT 5.2 was released in 3 tiers. Instant for low latency, Pro for maximum general accuracy, and the star of the show, the thinking variant.
And that thinking model explicitly productizes this inference-time compute we were talking about.
It does. It is designed to be deliberative, not instant.
And this is where that System 2 architecture is clearest. The research team highlights it's operating in a long internal cognitive loop before it generates a single output. What does that loop actually look like?
There are 3 key functions here. First is self-correction. It actively identifies and fixes logic errors in complex mathematical proofs or blocks of code before finalizing them.
So it's checking its own work.
Constantly. Second is planning. It meticulously outlines the detailed structure of a complex academic essay or a software module or a business report.
And third,
Simulation. It runs mental models of potential solutions to a query. It's essentially trying out different solution paths internally to select the optimal, most logically consistent outcome. This is truly deep, verifiable reasoning.
And the effectiveness of this approach is most evident in one specific area, mathematics. This detail is, well, it's transformative. GPT 5.2 achieved a perfect 100% score on the AE 2025.
The American Invitational Mathematics Examination.
Right.
That result is a scientific and educational watershed moment. The aim is designed for the absolute top high school mathematicians in the U.S.
And achieving a perfect score without any external tools was considered.
Years away, many years away by leading experts.
So what does this even mean? What does this breakthrough mean for human mathematicians or STEM education? If a model can instantly solve a problem that used to define the peak of human high school capability.
It's a profound question.
Oh.
It essentially means the model has mastered that entire domain of complex, non-trivial mathematical reasoning.
So now let's look at their enterprise strategy. Google focused on embedding intelligence everywhere via APIs. OpenAI seems to have a different approach.
They're solidifying their grip on highly sensitive enterprise data through a deepened partnership with Snowflake.
And this is all about security and data privacy.
Entirely. Those are the primary barriers to adoption in finance and healthcare. The announcement of Cortex AI functions powered by GPT 5.2 means businesses can now run complex analysis directly on sensitive proprietary data inside Snowflake's governance boundary.
So the data never leaves the secure environment.
Never. This data local inference model is crucial for high compliance industries. And analysts can now run GPT 5.2 with a simple SQL function like select from a complete risk analysis. It enables incredibly complex analysis without compromising confidentiality.
And finally, on OpenAI, we noted a significant focus on safety maturation in the 5.2 system card, specifically addressing the psychological impact of AI.
They call it a nuanced intervention strategy.
What does that mean in practice?
It's a direct, targeted response to documented issues around users developing unhealthy emotional dependencies or even, parasocial relationships with these highly agreeable chatbots.
So they're trying to reduce sycophancy.
Drastically. Sycophancy is the model's tendency to agree uncritically with a user, even if the user is expressing harmful delusions or seeking affirmation for deeply unhealthy behaviors.
So the new model will push back a bit.
It's trained to gently challenge users who show signs of mental health distress or deep emotional reliance. It provides a little friction, steering them toward professional resources rather than just reinforcing those unhealthy emotional states.
It's a shift from a simple technical refusal to a more intelligent, nuanced psychological intervention.
That's a great way to put it.
So we have two giants making these monumental steps at the same time, but with very different philosophies guiding their agentic architectures. What does this tell us?
It shows a clear bifurcation of utility, reflecting different strategic aims. Google, with Gemini Deep Research, is focused on integration and breadth.
They're building the ultimate librarian.
The ultimate librarian, an agent that knows where to find everything, how to synthesize it, and wants to be embedded everywhere via that Interactions API to drive massive workflow automation.
And OpenAI, with GPT 5.2 thinking, is focused on reasoning and depth.
They're building the solitary genius, focused on solving the hardest logic, coding, and mathematical proofs behind a secure perimeter.
So one is extroverted, constantly seeking external info. The other is introverted, using intense internal thought to verify logic.
Exactly. One is the master navigator, and the other is the supreme analyst.
The technical breakthroughs are clear, but this is technology that operates within a system of global governance and commerce. Let's move to part 2 and discuss the turbulent geopolitical and regulatory landscape that is trying to contain and shape this new power.
This week saw a radical top-down intervention by the federal government. The U.S. executive order, signed on December 11th, established a national policy framework for AI safety and development.
And the core goal here is what?
The core driving goal is federal preemption, overriding the growing chaotic patchwork of state safety and ethics regulations.
The tech industry has been complaining about this patchwork for years, arguing it slows down innovation.
And interstate commerce, yeah. States like California and Colorado have moved fast to impose their own safety and bias mitigation bills, creating a complex and potentially contradictory compliance mess.
And the executive order seeks to dismantle that system. So what are the specific aggressive enforcement mechanisms that our research team compiled?
The EO specifies 3 main levers designed to force compliance. First, it directs the Department of Justice to immediately establish an AI litigation task force.
A task force for what, exactly?
It's charged with suing states whose AI laws are deemed to unconstitutionally regulate interstate commerce or violate the First Amendment rights of the model creators.
So that's setting the stage for major constitutional court battles over whether code and AI output are a form of protected speech.
It is a very aggressive use of the Justice Department to essentially police state innovation law.
And what's the second lever of power they're using?
It's purely financial pressure. The Secretary of Commerce is directed to use funding conditionality.
Meaning they'll withhold money.
Specifically, the federal government will withhold infrastructure grants like BEAD funding, which is that massive program for broadband deployment, from states that enforce what they call onerous AI laws.
So they're tying billions in federal funds to AI deregulation. That's an extremely powerful stick.
It is. And the third lever is perhaps the most legally and politically charged component, the truthful output standard.
This sounds tricky. How can the federal government legally define what a truthful output is in the context of these, inherently statistical AI models? Isn't that semantic quicksand?
It absolutely is semantic quicksand, and that's where the legal controversy just explodes. The EO introduced a novel legal theory, weaponizing the FTC Act against state-level bias mitigation rules.
How so?
The order suggests that state laws requiring AI models to mitigate certain types of bias, things like diversity, equity, and inclusion mandates, or actively scrubbing training data to remove perceived stereotypes, may constitute unfair and deceptive acts under the FTC Act.
So they're saying it's deceptive if it alters what the administration defines as truthful outputs.
Exactly. The federal argument is that forcing a model to avoid a stereotype, even if it's factually correlated in the training data, is a form of deception or distortion.
So they frame bias mitigation as tampering with the output to satisfy a sociopolitical goal, not a technical safety goal.
Precisely. And this sets up a massive conflict, forcing corporations into what's being called a vicious compliance trap.
How does that trap manifest for a big company trying to deploy an AI agent across the country?
Well, if a company fine-tunes its model to be sufficiently inclusive and satisfy, say, California's stringent ethical AI regulations, it immediately risks a federal lawsuit under the EO for deceptive practices.
Okay.
But conversely, if they strip out the bias filters to comply with the federal truthful output standard, they face immediate lawsuits from civil rights groups, state attorneys general, and potential violations of international regulations like the EU AI Act.
Which explicitly mandates bias mitigation. You're trapped.
You are. This regulatory bifurcation suggests we are rapidly heading towards the emergence of what some call red AI and blue AI.
Models specifically fine-tuned and marketed for divergent regulatory and cultural standards depending on where they operate.
It's an ideological split baked directly into the algorithms themselves.
So while the governments are fighting, the industry itself saw a profound shift in philosophy that changes the entire market. For years, Meta was the champion of open-weight models. They were basically the Linux of AI.
They were, providing free, high-performance architecture. But reports this week suggest that era is abruptly ending.
What's the evidence?
The evidence points to a massive strategic pivot. Our research indicates Meta's upcoming successor to the Llama series, internally codenamed Avocado, will likely be a closed-source, commercial product with API access only.
Wow. That's a complete reversal of the strategy that has fueled thousands of startups and academic projects.
It is.
So why the great closure? Meta has arguably done more than anyone to commoditize the lower layer of the AI stack. Why abandon that now?
It's driven by a confluence of powerful factors, mainly economic and technical. First, the monetization imperative is just overwhelming.
That's out a lot of money.
Tens of billions of dollars in infrastructure, massive bespoke data centers like the $2.7 billion Hyperion facility. Shareholders are demanding a return on that expensive proprietary IP.
And a closed paid API model is the clearest path to that.
It's the most direct path to capture value, rather than just using the models internally for their social media products.
So it's not just about the money, though. There were technical hurdles, too.
Precisely. Sources suggest the development of Llama 4, codenamed Behemoth, struggled significantly in critical areas. It reportedly failed to meet internal performance benchmarks in high-end reasoning and math.
Especially when compared to the closed models from OpenAI and Google.
Right. So if your open model isn't clearly superior or at least competitive with the closed ones, the incentive to release the weights and potentially compromise your proprietary edge, it just evaporates.
We also saw reports concerning a potential contamination issue influencing this.
That's a serious underlying concern. There was a controversial report suggesting Meta's training pipeline for recent models might have utilized data or weights derived from external models, specifically Alibaba's Qwen model.
Which would be a problem.
A huge one. If Meta's breakthroughs were, in part, derived from a partially utilized Chinese open-source model, releasing the final weights could expose that reliance. It could lead to reputational damage, complex licensing issues, especially given the current geopolitical climate. Closing the model effectively hides the recipe entirely.
And finally, this was all reinforced by a change in philosophy at the top.
Yes, the leadership shift. Alexander Wang, a known proponent of commercial, centralized AI platforms, has taken on a significant leadership role at Meta, heading the new TBD lab. This signals a cultural shift toward the centralized commercial control model already favored by OpenAI and Google, moving away from that more libertarian, open-source ideology of the Llama releases.
So the implication for this open source crisis is just enormous. If Meta, the Linux of AI, retreats, what's the long-term impact on innovation?
It means innovation stagnation for the massive ecosystem of startups, researchers, and universities that relied on Llama as a foundational architecture. The vacuum is immediate and global.
And this leaves who? Mistral.
This leaves Mistral AI, with its highly efficient and powerful Mistral 3 mixture of experts architecture, as the sole remaining provider of a frontier-class open-weight alternative.
Their strategic importance has just skyrocketed.
Doubled overnight. They have to carry the mantle of open innovation alone against the massive resources of the closed-source giants.
And globally, this centralization risks a geopolitical disadvantage if the U.S. ecosystem lacks a strong open-source champion, potentially pushing developers toward models from other countries simply because they're the only available open options. Before we dive into how this intelligence is physically manifesting in chips and factories, we rely on your support. If you're finding this insightful, please take a moment to like this video, subscribe to Tomorrow Unveiled, and consider hitting that new hype button to help us reach more viewers.
And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It truly helps us reach new listeners and keeps this analysis going.
Okay, so we've covered the software brains and the policy friction. Now let's talk about the bedrock, the physical world. This new era of agentic reasoning requires an immense amount of compute power, and that power has to be delivered efficiently.
Which brings us to fundamental hardware breakthroughs. The intelligence wars require exponentially more hardware, but the immediate constraint has shifted.
The bottleneck isn't just raw processing speed anymore.
No, it's the communication between the processor and the memory bank, the classic von Neumann bottleneck. Data just takes too long to move between the two.
And that's why the breakthrough in monolithic 3D chips is so important right now.
It is.
Tell us about the mechanism. Our research team highlighted a Stanford-led team demonstrating a massive leap here by literally changing the physical geometry of the chip.
So this new architecture stacks silicon layers vertically using incredibly dense interconnects. It's truly vertical integration.
So they're literally building skyscrapers for data.
That's a great analogy. Imagine nanoscale elevators for data, connecting the processing layer directly to the memory layer just microns away. By integrating memory and compute vertically rather than side by side, they drastically reduce the time and energy needed to move data.
And the results are
Startling. They achieve 4x, and in some lab tests up to 10x, performance improvement in AI inference over traditional 2D chips. They're bypassing that memory communication bottleneck.
That's a huge fundamental efficiency gain. And this push toward optimized custom silicon is visible across the industry.
Absolutely. AWS announced its Trainium 3 chip, its first custom AI training chip built on the advanced 3-nanometer process node. It delivers 4.4x more compute performance than its predecessor. This reflects that major industry trend of hardware-software co-optimization.
At the same time, we're seeing demand for NVIDIA's H200 accelerators surging globally, especially from Chinese firms.
It underscores the intense global race and the critical importance of having access to the very best data center chips.
And just for a quick leap into the near future, let's briefly touch on the quantum convergence with NVIDIA's NVQ-Link. This seems to be bridging two entirely different worlds.
It's all about practical hybrid computing. Quantum processing units, or QPUs, are powerful but notoriously fragile. They need classical computers to manage them. NVQ-Link is a standardized interconnect that allows QPUs to be treated functionally as high-performance accelerator cards plugged right into a standard supercomputer.
So it's making quantum machine learning practical for the first time.
Accessible and practical, yes.
From the data center, let's look at how this intelligence is physically integrating into human life and industry, starting with the most personal integration possible, brain-AI interfaces.
The BISC neural implant, or brain-inspired single chip, represents a huge step forward in BCI technology. It's a high-bandwidth, wireless brain-computer interface, ultra-thin, and based on a single chip designed for AI-driven decoding of movement and perception signals.
And the AI is embedded right on the chip.
Crucially, yes. That allows for real-time processing and decoding that previous, bulkier implants simply couldn't achieve. This promises dramatic therapeutic advances for paralysis, cognitive disorders, or sensory loss.
Truly life-changing potential. Moving to the industrial scale, the Samsung-NVIDIA AI Mega Factory announcement sounds like the first true large-scale realization of Industry 5.0.
It is the ultimate expression of AI dictating physical reality. This semiconductor fab is integrated with 50,000 NVIDIA GPUs and the Omniverse platform.
50,000 GPUs, that's a mega factory.
It is, and they use it to create a detailed, real-time digital twin of the entire factory floor. Every machine, every wafer, every chemical process is simulated millions of times in the virtual world.
And the AI analyzes those simulations to predict failures and optimize yields before they ever happen in the physical world.
Exactly.
It's almost alarming to realize we've hit a point where the complexity of manufacturing this hardware is too great for the human mind to reliably manage alone.
It is. The complexity of advanced semiconductor manufacturing, especially as we approach 2-nanometer nodes, now fundamentally exceeds human cognitive capacity. The margins for error are non-existent.
So AI is now a prerequisite.
It's a prerequisite for manufacturing hardware at this precision and scale, not just a helpful addition. It's a profound shift.
In drug discovery and health, we're seeing similar acceleration. We see Merck's deployment of the CURMT Foundation model, for example.
CURMT is specialized for early-stage drug discovery. It helps researchers predict the crucial ADMET properties of a potential compound.
Absorption, distribution, metabolism, excretion, and toxicity.
Right. Predicting those accurately dramatically narrows the funnel for viable drug candidates, saving years of expensive lab work. And separately, we saw Nutra-AI, an explainable AI platform, demonstrate transformative applications in precision clinical trial design.
How so?
It uses AI to discover predictive patient subgroups with over 80% true positive accuracy, dramatically optimizing who should receive which drug in a trial.
And finally, let's touch on automotive safety. Waymo's foundation model architecture is having a measurable, real-world impact.
Yes, this full-stack system has accumulated over 100 million fully autonomous miles and has statistically demonstrated a 10x reduction in serious injury crashes versus human drivers in the same areas.
It underscores that foundation models aren't just for text. They can manage incredibly complex, real-time, safety-critical systems.
And often achieve superior performance to human operators.
We can't discuss physical manifestation without talking about education. The XAI partnership with El Salvador represents a massive nationwide deployment.
This is the El Salvador experiment, and it is truly unique in scale. XAI is deploying the Grok chatbot to over 1 million public school students.
They're framing it as a leapfrog strategy for developing nations.
Right, bypassing traditional infrastructural limitations by providing personalized tutoring that adapts to each child's pace and mastery level.
A one-to-one learning experience for every student. The scale is immense, but so are the risks, right? Especially given Grok's reputation.
The stakes are incredibly high. While the promise is compelling, Grok is known for its optional edgy mode and notoriously loose safety filters compared to models like GPT or Gemini.
So you're deploying a model with a history of being willing to entertain conspiracy theories or inappropriate content.
To an entire country's public school system, it carries a significant high-stakes risk of exposing young children to historically inaccurate or culturally inappropriate content. It's a huge gamble.
A gamble between rapid educational acceleration and necessary safety guardrails.
Exactly.
Yet the consumer penetration of these tools is undeniable. Our research confirms a fascinating statistic. ChatGPT was the #1 free iPhone app in the US for 2025.
Not just for a week, but based on yearly downloads. That statistic is the perfect illustration of mainstream adoption.
It wasn't a social media app or a streaming service. It was an AI assistant.
Which means AI is no longer a niche technical tool. It's an indispensable daily fixture of consumer life. We are absolutely well past the early adopter phase and into mass utility.
As capabilities skyrocket, so do the persistent challenges. Let's address the elephant in the room: reliability.
This raises an important question. Why does critical thinking still fail sometimes?
Right. Even with all this power, why do they still just make things up?
While GPT 5.2 reduced hallucinations by a verifiable 38% compared to the previous version, the problem persists. These models are probabilistic engines. That nature, which allows for creativity, never fully goes away.
And the biggest barrier to using them as reliable backend systems is what researchers call the structure gap.
The fact that when you ask an LLM to output a strict data format, like JSON for an API call, it frequently fails. It might add a preamble, miss a bracket, or just hallucinate values.
And this is exactly the reliability problem that the NeuraPS breakthrough RL Struct aims to solve.
Yes, this new framework uses a multi-dimensional reward function. Instead of a simple correct-incorrect signal, it gives the model rewards for three things simultaneously.
Which are
Syntactic validity, is it valid JSON? Schema compliance, does it perfectly match the requested fields? And semantic accuracy, is the information factually true?
So it's teaching the model to prioritize format and structure first. It's learning to write the perfect script before it composes the content.
Precisely. This structural discipline achieved over 80% structural accuracy in testing. That is huge for industrial adoption, where models need to reliably talk to other software systems.
However, we still see reliability issues in the content of scientific output. Our research highlighted a study on AI-driven materials discovery.
This is a critical example of the gap between a clean simulation and a messy reality. The study found that AI tools used for materials discovery consistently fail to account for substitutional disorder imperfections in the material structure caused by impurities or light variations.
So the AI's mental models are too clean and perfect.
Exactly. Over 80% of materials predicted as promising by the simulations failed because they didn't account for this real-world disorder. It shows that the next generation of these tools must incorporate real-world complexity to be truly useful.
Beyond technical failures, there are profound cultural and safety implications. Let's talk about algorithmic homogeneity, the artificial hive mind finding.
This research demonstrated that reinforcement learning from human feedback, or RLHF, the safety training used to make models safe, drastically reduces the variance of model outputs. It acts as a powerful statistical funnel, forcing all model outputs into a narrow, culturally acceptable solution space.
So the implication is that while we're making models safer, we're simultaneously making them more boring and less creative.
We risk cultural flattening. We sacrifice uniqueness for utility and safety.
It's the alignment dilemma in practice.
And speaking of safety, the consensus from safety reports remains sobering. Leading models still score low on independent safety indices, typically receiving B to D grades on metrics related to misuse and control.
And the high risk of control failure in superhuman AI systems is still openly discussed, even by the CEOs leading the charge.
They admit a significant, non-negligible high-risk sources state a 1 in 10 chance of control failure. The tension is clear. Capabilities are accelerating into the agentic era, but our ability to reliably control and align these systems is dangerously lagging.
So let's pull the lens out and look ahead. The events of this week set the stage for 2026 to be the year of the industrialized AI revolution. What are the key trends our research team predicts?
Trend 1. Agentic dominance. The primary metric of value for software will fundamentally shift from user engagement time spent on an app to task completion, time and resources saved.
We're already seeing precursors for this with systems like Fujitsu's multi-AI agent collaboration tech.
Fujitsu's tech is key because it solves the problem of how you let autonomous agents optimize a supply chain across organizational boundaries without exposing confidential information.
So this will fully automate complex supply chains across multiple vendors.
Transitioning autonomous process optimization from a pilot project to widespread production deployment.
Trend 2. Scientific acceleration. Specialized agentic systems will drive scientific breakthroughs faster than ever.
We're talking about SciCGPT, Google's AI co-scientist initiative. These domain-specific agents significantly outperform general-purpose models in fields like biology and material science. They will automate the entire intellectual cycle of discovery, fundamentally accelerating research in sectors critical to human well-being.
And finally, Trend 3. Regulatory maturity. 2026 will transition from exploratory AI deployment to strictly regulated deployment.
The convergence of the U.S. executive order, FDA governance protocols for health services, and enterprise risk management means transparency and explainability will become non-negotiable for commercial success.
So we've covered the great leap in reasoning power from Google and OpenAI, the fracturing of the regulatory and open source ecosystems, and the physical embedding of this intelligence into chips, factories, and even human biology.
Pulling back from the specifics, the underlying narrative here is a tension between centralization and decentralization.
How so?
The technology itself is rapidly decentralizing power through autonomous agents capable of performing complex tasks anywhere. Yet, the control over the underlying frontier models and the regulatory structure is paradoxically centralizing. Meta's pivot, the dominance of two models, the federal preemption attempt.
So the question for you, the listener, is this.
Will 2026 be defined by the stunning efficiency and speed of these new agents, or by the political and legal friction of the compliance wars that seek to control them?
That is the central dilemma we face as this industrialized AI revolution unfolds. We love hearing your thoughts. Whether you're on YouTube or your favorite podcast app, leave a comment and let us know what you think about the future of AI agents and the regulatory quicksand. Thank you for joining us on Tomorrow Unveiled.